We're now going to do an application problem where we're trying to find a maximum. So the problem we have says John has 80 yards of fencing with which to enclose a rectangular garden if the garden is X yards wide. Okay, now whenever we can, I suggest that you draw a picture. So we have this rectangular garden and we're saying it's X wide. So that would be X and this would be X. Now, if we have 80 yards total, well, we've already taken away 2x of that. So 80 minus 2x is what we have left for each of the sides. And if we divide that by 2, so we get half for one for this side and one for this side, they're the same length. We have to divide each of the terms by 2, so it would be 40 minus x for this side and this side. Okay, so the first part A says express the garden's area as a function of the width. Now the area, what's inside here, remember, is length times width. So the area, which we'll say A of x, that, remember the A is just like the name of the function, is going to be length. So we'll take 40 minus x times the width x. And if we want to distribute that x, we can write this as 40x minus x squared. So we're just taking this x times the 40 and the x times the x. Now, the domain of this function, oops, sorry, that should be a b. I was thinking b and thinking domain. Okay, the domain, remember, are what x values are allowed to be plugged in. And our a of x, that's just a polynomial, so we would think it would be negative infinity to infinity. But we have to think about the context here. In the context, we know that we can't, if we're talking about how wide something is, it can't be less than 0 yards wide. And here, if we have 80 yards of fencing, it can't be wider than 80. Okay, so our domain here is actually from 0 to 80. Okay, part C says graph the function and use the maximum feature to find the dimensions that yield the maximum area. Okay, so we're going to turn this on and we're going to go to our y equals and we're going to graph this function, 40x minus x squared. Okay, so let's look at that graph. Okay, and look, it doesn't fit at all. Let's try the zoom fit to see if it gives us, so I just hit zoom 0. We want to see the top, and we still don't see the top. Okay, so let's try zooming out. Sometimes with these graphs, the best, there's not much to do other than just really try the zoom features. Okay, now we can see the top of the hill, the relative max. So we're going to do second calc 4 for maximum. Now we're already to the left of the hill, so we can hit enter for left bound. We're going to move the cursor so we get over the top. Hit enter. Hit enter again. And we see that the maximum is at x equals 20. Well, so that would be the width. Oops, sorry, I can't write today. Now, the length, we know, is 40 minus x. So the length would be 40 minus 20, so the length would also be 20. So the dimensions here that give us the largest area would be 20 by 20. So 20 yards by 20 yards. And that's a square. And remember, that's okay because a square is a rectangle.